Testing 1, 2. Can you hear me? Okay, cool. Well, I'm not sharing anything, so I don't think my video works. Let me just turn the video on. Is that good? Oh, wrong. Oh, that's the wrong angle. There we go. Yep. Okay, yeah, thanks. Hi, good afternoon, good morning, good evening, and good everything to everybody wherever in the part of this beautiful world that you are today. Welcome to another awesome, afternoon. To sit here and chat with two wonderful people. We have Elmar and we have Cristiano, and today they would give us some real insight into things. For those of you who don't know me, I've been around here for a while. Good, nice beard. Yeah, I'm Larry Goddard. I am the test automation architect. I am also a co-author of a book I wrote, and here we go. Good old enhanced test automation with WebDriver IO. Get your copy. It's on Amazon. And yeah, outside of that, like I say, I'm the test automation architect. I like to dabble in things. I do a lot of other bits and pieces. I do mentoring. I officiate in basketball. I train people and things, and all that. So that is what I do. And outside that, besides my day job, I get along with all those things, and then I take the time to do these hosts to bring these lovely people awesome help of with the awesome help of Zapotec. And Zapotec have been around long, and they do this hosting, and it's a very good thing. So that's why we are here, and we do that. So today we have with us. I will talk about my first guy today. He's Elmar. His name is Elmar, and I will not try to pronounce his name. I'll let him do that so that I won't pronounce it wrong, and then he'll have to beat him up in the background after he talk. So we'll avoid that. Yeah, there he is. So, to avoid it, I'll let him introduce himself and say. So, Elmar I will give you a little bit of him. He's a founder, a great keynote speaker, and he's one of them guys and them who love helping companies improve the quality of their mission critical software systems. Now, that's a whole mouthful. That's a mouthful, but I know we have the kind of eloquent guy there. And what he's going to talk about today, he's going to give us some insight into test intelligence and how can we find more bugs in less time. So that is what we'll do today. So without further ado, I will now turn over the floor, and I see my good man Elmar is there. Elmar, the floor is yours.
Larry, thank you very much for the introduction.
Yeah, my pleasure.
Let me just share my screen so that I have some slides to back up what I'm going to present. Are the slides on air?
Yes, we can see the slides.
So as testers and test automators, we're faced with the challenge that we have to test more and more functionality in less and less time. We saw because successful software grows from release to release, so that we have to test it more and more. But paradoxically, we get less time to test more functionality because release cycles are shortening. And I am convinced that we can only overcome this challenge in the long run if we get more effective and efficient at the same time. And this is where my talk comes in, because test intelligence is a name for a bunch of software analyses that mine the data from our development and test process to help us be more effective and efficient, or in other words, to find more bugs in less time. And I want to both present the research background and sketch out how these analyses work, and show you examples from practice so that you get a gut feeling on what they are capable of and also what their limitations are. And before I start, I have a question, or I want to ask a favor of you. If you have questions, please interrupt me directly. Put them into chat, and then Larry can interrupt me and ask me the question. And it needs not be a well-articulated question. As you know, testing looks very different from company to company. Test automation looks different from test automation framework to test automation framework or tool. So if I present something that does not resonate with how you experience your testing environment, please bring this to the chat, then we can discuss that. I much prefer if this gets interactive and you take out of the session what you want, than that I get through my slides in the order that I brought them. So with that out of the way, the key idea I want to present is that we need to get transparency into the black box of software testing to see what changed since the last tests we did. which tests can execute which code, so that we know which tests to run now or to manually perform now. And because it sounds a bit buzzwordy to say that we need to bring transparency into the black box of software testing, I want to start with a non-testing example that all of you know from medicine, namely X-ray pictures, which bring transparency into the black box of our body. This is an X-ray picture of a kneecap, more specifically of my right kneecap, which I unfortunately broke a couple of years ago in an accident. And those bright fat lines here are the wire pieces that hold together the pieces of bone. And the small wiggly lines are the clamps that close the scar. Sorry, I threw my mouse across my machine. Now we're back at the X-ray. So why do I bring this as a testing example? Because obviously, I mean, you don't plan for an accident, you don't plan for the surgery, but 2 weeks after the surgery, I was made to go to the doctor for quality assurance. And what I found very impressive in retrospect is that, to speak in testing terms, the doctor did not retest all. He didn't even ask me how I feel. He didn't take a blood sample. He didn't measure my temperature or blood pressure. Instead, he took this picture to see if the change the surgeon made resulted in what he expected my bones and stuff to look like afterwards. So it was a very specific quality control approach that saved a lot of effort on his part. And I want to take over this metaphor to software testing. And obviously, we don't have X-rays that can work on software because software is not a physical thing. So instead, we have to make do with the data sources that accumulate changes in data during our development and testing process. So on the one hand, so I'm going to talk about 3 data sources today. And the 3 are the version history that contains all the code base, all the code changes, all the branches made by all the developers that have ever contributed to the software. Second, the tickets or issues or change requests or user stories or bugs. They go by different names, but they are descriptions of the unit of work that live in some ticket system, like Jira or Azure DevOps. And the third data source is test coverage or code coverage, which captures which code gets executed during testing. And I use the terms code coverage and test coverage synonymously in this talk. And my agenda today is as follows. I want to highlight 3 questions that we can answer using this data. And the first one is, where were the most bugs in the past? Because often, if there's a systematic problem in our development or test process, we can see it by bugs accumulating in a certain area. And if we learn about this, we can target this problem at its root. The second one is, where are untested changes? Because in long-lived software, most of the changes occur in most of the bugs occur in those areas that were changed since the last release. And the third one, and I think that's especially interesting for you, for those of you that are interested in test automation, is which tests are most valuable right now. Because a lot of our customers or the teams we work with have very many automated tests, and they run many hours or days, or in some cases, if a lot of hardware is involved, even weeks to rerun the entire test suite. And this is a very long time to wait for a test result. So in this question, I want to look into which small subset of tests can we execute now that has the highest likelihood to find new bugs very quickly without waiting for hours, days, or weeks. So before I dive into those questions, some background on me so that you can place where those experiences that I'm going to present come from. I'm a computer scientist. I studied informatics in Munich and did my PhD in software quality analysis. And I brought for your entertainment how I looked back then and when I started my PhD, and then how I looked when I finished my PhD and started the company. And I've been told that it mostly shows that I always got enough food. But the key message I want to send here is that I look at the topic of software quality and test intelligence through 2 lenses. As a researcher, and I'm still working as a postdoc and supervise some doctoral students. As a researcher, I'm interested in what is really relevant to know about tests. Because unfortunately, often we measure what is easy to measure and not what's relevant to know. And in the founder role, I'm interested in impact. Just by stepping on the scales every day, I unfortunately don't lose any weight. And just by running some software analysis that inspects tests or source code, nothing improves. So in the founder role, I'm interested in how these analyses need to look like and how they need to be incorporated into processes to really result in better software. And CQSE is a spin-off from the Technical University Munich. I'm one of the founders. We are 62 right now, and 58 of us are computer scientists, and 23 of the computer scientists hold a PhD in software quality analysis. So the experiences I'm presenting are from our group and not from me alone. Last slide on background. This is a couple of the companies we work for. And the key message I want to send is that even though obviously testing looks different for a COBOL system running in a bank or a Java or C# application that lives in an insurance company or an embedded system driving in a car. But if we take a step back, the challenge that we have to test more and more functionality in less and less time is present across all those companies and organizations. And the approaches I present are independent of a specific programming language or domain or organization type. So enough background. I think most of you know that software is written in code and that changes are documented in tickets. But from my experience, different people understand different things when I say test coverage or code coverage. So before I dive into the analyses, I want to quickly recap what I mean by test coverage so that we are all on the same page. And for that, I like to use an open source project written in Java called Pixelitor as an example system that I use to show test coverage and for the other analyses later on. This is a screenshot of Pixelitor. You can imagine Pixelitor like MS Paint or a very simple version of Photoshop. It allows you to paint images or edit them and has some blurs that allow you to change the image. And this is a piece of code from the Pixelitor written in Java. One single method called create and show GUI. And it's not important that you read the code or understand the code now for the talk. The key message I want to send here is that code coverage measures which code gets executed while tests are run. And there's software called code coverage profilers that fully automatically capture code coverage in the background. And here you see all the lines that have a green background have been executed during the test, and the lines that have a red background have not been executed during the testing. And the typical use case in practice that we see most teams that use test coverage employ is that they capture test coverage of automated unit tests, and then they look at the test coverage to see, does it match the expectations? For example, in this case, here's an if statement, and the body of the if statement, those two lines, 125 and 126, they are red. That means they were not executed by the test. And now as a developer, I can think, do I need a test for that? Maybe I write another test. So to recap, it captures which code gets executed during testing and is usually only employed for automated unit tests. But today, I want to use it for the entire system testing and not only for single methods. And I want to use it for all types of tests, not only automated unit tests, but also end-to-end tests and manual tests. And to give you an impression of what the data can tell us, I like to use so-called tree maps as a visualization. And a tree map uses rectangles to visualize software components. And this is a tree map of the package structure of the Pixelitor. So every big rectangle here is a package. And the size of the rectangle corresponds to the length of the component in lines of code. And now I zoom in. the components stay in place, and the smaller rectangles now are files or Java classes. And if we go in even further, the tiny rectangles are methods of the pixelator. And it still holds that the bigger a rectangle, the bigger the corresponding method in lines of code. And now I use this visualization to depict test coverage. This is the coverage of the automated tests of the pixelator. Gray means it was not covered during testing, and green means it was covered during testing. In other terms, that means if there's a bug in gray code and we run the tests will never go through code that contains the bug, so we cannot find the bug. If there's a bug in green code and we run the tests, we have a chance that the test runs through the bug and notices the bug, but not a guarantee, because just because a test executes code that contains a bug does not necessarily mean we really find the bug. It always depends on what the test really checks for. So I use test coverage for the entire system and also for manual tests or end-to-end tests. And to drive this home, I have an animation here, where on the one hand side, you see a tree map of pixelator. And on the other hand side, we will see a manual UI test we do in the pixelator. And we start measuring the code coverage when we start up pixelator. And the single green rectangle you see here is the start method. And now as I start the pixelator, on the left hand, you see the splash screen, and you see the UI loads. And on the right-hand side, you see the code that gets executed while the stuff on the left-hand side happens here. And here we use one of the blurs to test if the blur works. And on the right-hand side, you can see which code was executed. So the key message I want to send here is we can do manual testing, or we can do end-to-end testing with Selenium or Playwright or whatever, and still capture code coverage. And we don't have to change the way we do our tests, because the code coverage profiler works in the background without affecting the way we test the system. So now we've laid the groundwork to talk about the different analyses. And the first analysis I want to go into is so-called history analysis, where I want to look at where the most bugs occurred in the past. And for this analysis, we use all three data sources. On this picture here, you see a tree map from an industrial software system, roughly 1.5 million lines of code. Every rectangle is a file of the source code of that system. And the darker the color blue, the more often this file was changed during a bug fix in the last 3 years. And this is an approximation for how many bugs were in this file in the last 3 years. It's not exactly the same, because sometimes when a developer fixes a bug, they don't only touch the file that contains the bug, but maybe need to do some preparation in another file or find some minor problem that they can rectify during the bug fix. So there's some noise, but all in all, because there's so much data we analyze here, it's a very good approximation. The darker the color blue, the more bugs were fixed here in the past. So what do we see here? The first thing we see is not so interesting, which is the biggest files. The biggest files here are the darkest. And the bigger a file, the higher likelihood it can be part of a bug fix, so that's not so interesting. But the second thing that strikes the eye is that here in the middle, there's a big part that's much bluer than the rest, which means it contains a lot more bug fixes than the rest of the code for the same time span. What happens here? And for this system, when we wanted to understand what's happening here, we measured the code coverage of all the automated tests, for the automated unit tests, for the automated Selenium tests, and so on. And this is the picture we got. Now, this is the same tree map, the same files, but color means test coverage now. So the darker the green, the higher the test coverage in that file. And if it's white, there's no automated tests that run through that file. And you notice that there's a big white area in the center, where there's some tests, but way less than for the rest of the system. And now if we put those two tree maps on the same slide, you notice that it's exactly the region that contains the many bugs is the region that has the least automated tests. So when we found this out, we spoke with the team that builds this system. And we learned the following. On the left-hand side here, this is backend code. On the right-hand side here, this is also backend code. And in the center here, this is front-end code, written in JavaScript. The backend code was written in Java. And for some reason, nobody had ever laid the groundwork to make it easy to write automated tests for the front end. For the back end, there was a lot of unit test and automated test framework in place, so that developers would often write automated tests either before they implemented a feature or after they implemented the feature. But when they built a feature, they also built automated tests. But this was not true for the front end, not because the developers were not convinced that automating tests here was a good idea as well, but because the first step to lay the foundation to make it easy to write automated tests was never done and always postponed. And you can easily see that this was a big problem, because all the bugs here are the ones reported from users from production. And when we showed this picture to the team, it became obvious that this is not a sustainable way to do this project in the future. And in the next iterations, they planned the effort to lay the foundation to build better unit tests for the UI. And when we did the same analysis later on, we saw that the coverage had improved a lot, and also that the amount of bugs in that area had gone down compared to the rest of the system. So to summarize this analysis, from the data you have in your version control system, you can compute such information to see, are there hotspots where bugs are much more frequent than in the rest of the system? And in many cases, like in this case, this allows us to see a root cause of a problem in our quality assurance process. And it's a really simple analysis, because all the data you need from the version history is already there. You don't have to collect this before you can start this analysis. So now is a good time for questions regarding history analysis before I go to the next analysis. And I look into the chat. Please take the time to write more questions or comments while I read the first one. Paul Grossman asks, what is the tool to do this comparison? We have a tool called TeamScale, which we use for this, but the individual parts, like for example, selecting the bugs is from Jira. So the data you use is not specific to a certain tool. And because I don't want to make a sales pitch for our tool today, but instead talk about the analysis, because that's independent of the tool, I don't want to talk about our tool too much, but I will stick around, or you can contact me afterwards if you want to know more about the tool. Thanks for the question. Are there further questions?
Before I jump, I mean, just besides the tool, I'm looking at the way you scale out, the way you scale it out using your images. My question is, how would somebody looking at that know, that image, how would somebody, now looking at it, understand what it is being portrayed by it?
That's a good question. And the answer is, if you use a tool that produces tree maps, if you move the mouse over one of those boxes, you see exactly which source code is behind that. So okay. On the PowerPoint slide, you don't see this, but every single rectangle here is a piece of the source code. And source code is typically organized in a hierarchy where you have namespaces and sub-namespaces and then classes and then methods. And this namespace hierarchy or package structure is still available in the tree map. And then you can see, if you move the mouse across that, which part of the source code are we talking about? Are we in the back end? Are we maybe in authentication? Are we in the business logic? Are we in the UI? And so on.
All right, thanks for that.
Thanks for the question. And Paul, thanks for the nice comment. So I take this as a link to the next part of the talk, and please continue writing questions in the chat. So here we saw that there was a large area where we didn't test the changes prior to shipping. So the next analysis I want to talk about is how we can directly see if there are untested changes before we ship something into production. And why do I think this is interesting? Because many of the teams we work with have less effort or less resources available than they would need to test everything, independent of whether we talk about manual tests or automated tests that need to be written and maintained. And so we are forced to prioritize and would like to focus our testing on those areas that are most prone to errors. And fortunately, there's a whole research field called defect prediction that investigated which parts of a system are most prone to errors so that we should focus our testing efforts on. And what this research area did was, for 3 decades, measure prior to release properties of software, push them into a machine learning model, and then correlate them with the bugs they found after release. And what this area found out was that for long-lived software system, meaning everything we didn't start in the last month from scratch, for long-lived software system, most bugs are in those areas we changed since the last release. Now, as testing and test automation professionals, we will probably think, why do you need decades of research for that? Because that also is what our gut feeling tells us. But what we were really surprised is how many changes come into production untested, even in structured testing processes and approaches, because software development is so complex and has so many moving parts. So the basic idea of the next analysis is that we extract changes from the version history and superimpose that with coverage information from all our testing to see which changes we did not yet execute. Now, let's do a specific example. This is a business information system from Munich Re, world's largest reinsurance company, and they gave me the clearance to show this. It's written in C#, and at the point of time where I did this analysis, roughly 30 people worked for half a year. And on this tree map, you see the changes they performed to prepare the next release. Gray means the code didn't change since the last release. Orange and red means the code changed or is new. So here we see on the left-hand side, there's not so many changes. On the right-hand side, there's a lot of change in new code. So we would expect to at least test the right side very thoroughly because there's all the modified in new code. So this is one piece of information for test gap analysis. The second piece is test coverage. Same system, same tree map, but now green means covered during testing, and gray means not executed during testing. And again, it's possible to measure test coverage for manual tests, as you remember from my Pixelito slide earlier. So in this picture, we already have the aggregated test coverage of all test phases: automated unit tests, automated end-to-end tests, and manual acceptance tests and explorative tests that were run on the system. So how does it look if we compare that information? Now we see untested changes, and gray means the software did not change. The code was not modified. Independent of whether we tested it or not, this is gray because we know from experience and from research, we can expect way less bugs in those areas. Everything that's colorful here is the new and modified code, and only if it's green did we execute it during testing. Now, how do we interpret that? The green stuff, hard to interpret. We know it was modified, we know it was tested. We don't know if there are any bugs left. Because as you know, testing can never prove that there's no bugs left. We can only show we found bugs. But all the orange and red stuff is very easy to interpret. We cannot have found a single bug in there because we didn't ever test it. And here's tens of thousands of lines of code in every single one of these components, and they slip through testing entirely unexecuted. Here, if you look at those areas. And the key idea of test gap analysis is to allow you a conscious decision if you want to ship like this. We took this picture on the day before the scheduled release. And I mean, in theory, it needs not be a problem that those massive components were not tested, because it could be that they don't need to work at this moment in time. For example, business information systems often have some type of seasonality. For example, some functionality is only needed at the end of the business year, and maybe if your business year ends in March, you don't need that functionality in June. So it could be that it's not problematic if it's broken. However, in this case, this functionality was expected to work. I mean, they built this specifically for the new release, all the red stuff. So the team decided this cannot be shipped like this, and had another testing phase before they went into production. So this perspective on test gap analysis is for the entire system. And the role it's most useful for is the person who's in charge of the entire testing or QA effort. However, from my experience, often I'm interested in a smaller scope of test gaps, namely individual tickets or issues. And if I talk to different teams, an issue has a different name. Sometimes it's called issue, sometimes bug, sometimes user story, sometimes change request. So whenever I say ticket, please translate that into what it's called in your environment. This is a screenshot from our own development. We use our tool TeamScale for the development of TeamScale itself. And we capture test coverage for every single ticket. And if I click on a ticket, I see a small tree map that only shows those parts of the code that were modified during the implementation of that ticket. And in our experience, this makes it easier to prioritize different test gaps, because often if you have such a picture, there's too many test gaps to still close until you have to ship. And then you want to focus on the most important test gaps. And it's easier to prioritize tickets than code, because the ticket is much closer to business risk than code from my experience. And in our process, you are only allowed to merge a ticket or a branch on which you have implemented the ticket into the release version if there's no non-trivial test gaps left. So here I wouldn't be allowed to merge this branch because there's still test gaps in here. Now, taking a step back, I brought another example how different of our customers use this to give you some more gut feeling how this can look in practice. And some of them use it as a big central repository for code coverage to see how different test stages and test types complement each other. For example, in some, maybe they have a lot of unit tests, but not so many acceptance tests, and they want to make sure that certain features were also hit during the acceptance test. And we have one customer, Munich Re, who has been working together with us for 15 years already, before we incorporated the company even, when this idea was still a research prototype. And with them, we analyzed some of their systems before we had test coverage available. And then many years later, when their CIO changed and he wanted to know if it's still worth to invest budget into the tool, Munich Re made an analysis what the positive effect of test gap analysis on their software quality is. And what they found out is that they reduced the number of bugs that go through testing by a factor of 2. So they've before 60% of the bugs that were in the software slipped through testing, and with test gap analysis, only 28% of the bugs that are in the software slip through testing. Now that sounds like a large number, But this is all the bugs you know about years after shipping into production. So not the bugs you encountered during development or testing, but in a retrospective view, when you have all the bug reports from many years of productive use, and then see which slipped through testing when. That concludes my second part about test gap analysis. Are there any questions or comments regarding test gap analysis? Then now would be a great time to type them into chat. My third analysis is about which tests to run if you have too many tests to always execute all of them. And the very basic idea is, let's select a small set of the tests that we execute more frequently than the entire test suite. For example, we have a customer that has 80,000 automated end-to-end tests, and they run for 400 hours. And even if they parallelize them in 50 environments, it takes them an entire night to execute them. And then they've only tested one version, but customers often have other versions or older versions of the software still deployed. So it often takes weeks between the point in time where a developer commits a change and breaks something and a failing test case revealing that. And this is very long. If I break something and a test tells me immediately, then I still know what I broke and I can fix this easily. If a test tells me 4 weeks from now that I broke something, then I have forgotten what I did today. And I've done so many things in between that could also be the root cause that it's way more expensive to find the bug then. So the key idea is, how can we select a very small part of the test that runs very quickly, but still finds most of the bugs that the entire test suite would find? Paul, thanks for the question. Could you give some context by what you mean, how long it takes? Like a test gap analysis typically takes a couple of seconds, so that between getting the data and seeing the test gaps, and the selection algorithms I'm going to talk about also take a couple of seconds. So you don't slow down the testing process by running these analyses. If you meant something else with the question, yes, gap analysis. The basic idea is that we capture all the data in the background so that you don't have to wait for the results of an analysis. And the only factor you have to wait for is the data transport between the different test systems and the test gap analysis engine. And depending on how your test environment is set up, this can take seconds or minutes, or sometimes if the testing happens in a different part of the company where there's firewalls and stuff, maybe you have to wait overnight so that there can be a data transport. But we try to have this as real time as possible. Herman, how can we discover bugs in configuration files like YML? Test coverage analysis seems not to be capable of finding out what happens. Correct. So this is one of the boundaries of any coverage-based analysis. It won't work on configuration files. There's one exception. There's some research work that monitors file system access. So then you can notice when a software system reads the configuration file. And if you're lucky and it reads the configuration file in the right moment, then you can use that also for the analysis. But this is like a theoretical answer because I'm not aware of any tool in practice that can do that. But one of the PhD students we worked together did this for his PhD thesis. But this is not part of any practical tool I'm aware of. Herman, thanks for the question. So coming back to test selection. I want to present two approaches to select fast test subsets. And the first one exploits the fact that most test suites are very redundant. And if we squeeze out the redundancy, we can find a small subset that covers most of the code and finds most of the bugs. And I want to go back to the Pixelator to give you a specific example of what I mean by this. Imagine we start the end-to-end test suite from Pixelator. And the first test in that suite is called Test Gaussian Blur. Blurs are an important feature of Pixelator. So there's test cases for the different blurs. And this is all the methods the Gaussian blur covers. The second test in the suite is called motion blur. What I forgot to say is we measured the test case specific coverage for this. So for every single test case, we measured which parts of the code does it execute. That's how we can draw these pictures, and that's also how these algorithms I'm going to present work. So at first we ran the Gaussian blur, and now we run the motion blur. And all the code that the motion blur tests that was not tested before is green. And everything the motion blur tests that was also tested by the Gaussian blur is blue. And you notice there's some stuff that's specific to the motion blur, but most of the code has already been tested by the Gaussian blur. The third test in the suite is called lens blur. The fourth test is called smart blur. And I mean, you notice it directly. Everyone is called blur, 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 and they test very similar stuff. So if we take a step back, and here you see the 4 tree maps, and to the right is the green areas they tested. You see the first one contributed a lot of coverage, and then there's saturation, and each subsequent tests contributes less coverage that was not previously tested. And empirically, we know through a lot of research that for most of the bugs in here, in the blue area, either all the tests find that or none of the tests find it. So from an efficiency perspective, it would be better to only test one blur and then test something completely different if we only have a little bit of time and want to find most of the bugs. And this is a chart from a real customer project, not from the Pixelator demo. And it's from a medical software where the tests run 48 hours. And on the right-hand side, you see the 48 hours. And on the vertical axis, you see the test coverage that the entire test suite produces. And what I want to show you is that there's a lot of these plateaus. And they mean that for hours, there's a lot of tests executing, but there's hardly any new software tested. And that's because there's clusters of similar tests, like those blurs. That's something we typically see in practice. And typically those clusters are, all of the clusters are executed one after the other before we start the next cluster. And the first test from the next cluster produces a lot of new coverage and can find a lot of bugs that the previous tests could not find. And then we spend a lot of time in that cluster again. So the key idea of an analysis called Pareto optimization is to reorder those tests in such a way that we very quickly get a lot of coverage. And there's very many different approaches. And the best approach we found that works for us is to always take that test case next, that per second of test execution covers the most untested lines of code. And if we run this on the Pixelator, we get the following result. Imagine we have this reordered test suite. The first test we run is called test create and modify selection. Because it's the first one, everything it tests is green. The second one is called change view settings. And you see there's some blue code, but most of it is still green. The third one is second layer. The third one is save image. It's not important what it does exactly, but you notice immediately it's not blur, 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 but very different functionality. And if we put those tree maps next to the ones before, you see that in the same amount of time we used to run automated tests, we have way more code covered. And if we come from the Pixelator example back to this one, if we run this algorithm on this data set, on this test suite, we transform this chart, where it takes 48 hours to reach 100% code coverage to this chart. And you see that it selects tests in such a way that very quickly we achieve very much code coverage. In other terms, here in 8% of the runtime, we cover 99% of the code that the entire test suite covers. And now I made a bit of a trick, because I spoke about optimizing coverage. But what we're really after is fault finding capability. And all of this only makes sense if coverage is a good approximation of fault finding capability. And to find that out, we did a lot of research. And by we, I mean our master thesis students and PhD students that we supervised. And the key questions we had is, if I take 1% of the time it takes to execute the entire test suite, how many of the bugs do we find if we optimize a test suite like that? If we take 5%, if we take 10%, and so on. And for that, we need a lot of bugs. And we had two sources of bugs. The first one was from open source systems. We crawled through many open source systems through historic versions to find instances where there were automated tests that failed. And then we would see if we also found that those failing unit tests, if we optimized the test suite in this way. And the second instance was mutation testing. So we automatically inserted thousands of bugs into open source systems to see if the optimized test suite would find that. The advantage of using historic bugs from real-world software is that they're very representative because they are bugs from real-world software. The disadvantage is it's very hard to get a lot of data. We analyzed thousands of versions to get like 50 bugs. The advantage of mutation testing is that it's very easy to get a lot of data, and the disadvantage is that it's not so representative. But combining those two approaches, they cancel the weaknesses out. And luckily, we got the same result for both approaches. So we are very positive that it holds for other systems as well. And in 6% of the time it takes to run the entire test suite, we find 80% of the bugs that the entire test suite can find. Or in 11% of the time it takes to run the entire test suite, we can find 90% of the bugs the entire test suite can find just by wringing out redundancy. So the key idea is that you separate your test suite into two different ones. The small one that you execute frequently, and the big one that contains all the tests that you still execute every now and then. And I have one example from a Bavarian customer, the Bayerische Versorgungskammer. I don't really know how that translates, but they build business information systems to compute pensions. And they had a test suite that ran 20 hours. So it would take an entire day to execute. So you would have to wait at least until next day if you broke something. And what we did with them was take 1 hour of time budget, like 5% of the 20 hours, and build the small test suite that fits into this 1 hour. And this gets executed with every build. But the big test suite still gets executed on a separate machine the next day. And this way, we get to speed up how quickly we find bugs, and also notice which bugs slip through and are found the next day, where you still have to wait as long as before. And we found with them, they've been using this for a couple of years now, that in the 5% of the test budget, they find 70% of the bugs that are in the software. And the remaining 30% are found the next day. So that gives them a big speed up, because often they can fix a bug, try again, if they have another bug, fix that, and so on, before, which would have taken several days beforehand. So the last, and there's one way to make this even better, and this is the last analysis I want to present. And the key idea which we add now is that we also look at what changed since the last test execution we did. And now I have an example from our own system. This is roughly 1.5 million lines of code. And because we analyze other software, whenever a programming language evolves, we need to adapt our analysis software. And the changes you see here were implemented when the programming language Java had a new version that contained a construct called closures. It had its own keyword and syntax, so we had to adopt our scanner and our parser and so on. And what I now do is run a time-lapse video of our automated unit tests. We run 30 unit tests per second. All the methods a single unit test execute are depicted in white in one frame, and then they fade to green, so that you see how the tests distribute and where they run. I start this now. I hope it comes through Restream. And to me, it feels a bit like a weather radar, where you see the flashlights going down. And you see that there are some areas which are executed by many different unit tests. You see the coverage slowly building up. But the most important point I want to make here is, if something gets tested, it first gets white and then green. But all the orange and red stuff is still orange and red because we didn't execute it during our tests. I stopped the time lapse now. Back at that time, we had 5,000 unit tests, and right now we have 18,000 or something. But of the 5,000 automated tests, only 4 executed changes we made for the ticket. Not 4,000, 4 tests out of 5,000. But only those tests, only those 4 can find a new bug in the modified code. All the other 4,996 cannot find a new bug because they don't execute any of the changes. And the key idea of test impact analysis is not executing tests that don't run through code that was not changed since the last time you ran your tests. So imagine you have all those tests. Every gray-green rectangle is supposed to signify a test here. And in the first step, test impact analysis throws out all the tests that are not impacted by a change. And if we have unit tests, in the sense that our automated tests test a little bit of code, this works very well. However, if we have end-to-end tests, and this is a picture from a Selenium UI test we had back then. Now we're doing most of the tests in Playwright. Everything you see here in white is run by a single test. And if I start the execution now, you see that there's a lot of code that gets executed by many of the UI tests because they have to go through the UI stack and back. And if you change a bit of code that gets run through by all the tests, you don't save anything because all those tests are impacted. So the second step, in case there's too many tests left, is to do the same reordering we had for the Pareto optimization earlier. So that you come from such a picture to such a picture where you hopefully have a failing test very early. So how well does this work? We did the same studies here as well. And we found that on average, in 1% of the time it takes to execute all the tests, we find 80% of the bugs. And in 2% of the time it takes to execute all the tests, we find 90% of the bugs. So better than Pareto optimization, where it took us 11% of the time to find 90% of the bugs, but also more effort. And we also have customers that use this analysis to speed up their CI pipeline, even in a very large parameter space. So to sum up, to compare those analyses, I presented 2 different ways of selecting those tests to run now, because they are likely to quickly find new bugs. Test impact analysis has the higher speed up, but also requires higher effort to set up and run, because we have to compute the affected tests for every single run on the fly. Pareto optimization is not as good, but much easier to set up, and also works if you, for example, can't compute the tests on the fly. For example, because you're on a big acceptance tests where you don't have access to the source code of all the changed modules on time. And some of our users employ this as an optimized smoke test before they run manual tests or before they run expensive automated test suites. They run an optimized smoke test to see if the software is good enough to be allowed into the expensive test phase. I'm just reading the question. Sorry, Michael, I don't have the context for the link. If that's a question, please give some more context. By the way, Michael, thanks for doing a great job hosting Eurostar. I really enjoyed my time in Stockholm 2 weeks ago. Let me wrap up because I'm 6 minutes before the end of my time box. I wanted to present to you today that the data repositories we have in our development and test processes have a lot of information that we can use to make our testing more effective and more efficient. On other terms, how we can use it to find more bugs in less time. And in my experience, a good way to regard them is as a toolbox. There are many useful tools, but they must be fit into your processes so that they work smoothly and really tackle the pain points you might have. And I'm really, as you hopefully have noticed, I'm really interested in this area. I've been working in this area for 15 years, and I'm happy to exchange my experience, for example, through a virtual coffee chat. This is the tool we work on. It's free for open source. It's free for research and teaching. For commercial software, it costs licenses because that's our business model. That's how we finance our company and the further additions of TeamScale. But I'm happy to talk over coffee free of charge. I think we have 4 minutes left. I'm just looking into chat, and I'm really happy to answer more questions if there are any, or just have discussions if you want to discuss something. Let me say thanks for your time at this point.
Yeah, and again, thanks for that. Very interested, and I see the good friend Michael, saying a sincere thank you for mentioning Eurostar. Yeah, well done, and good job, Mike. Good job. Before we go, I actually have a little question here. In terms of running the analysis and things like that, wouldn't it be better? And just a question out there: wouldn't it be better if the companies and or teams create less tests, and also refactor old tests than just building out thousands of tests that some of them that just doesn't have any value after a while?
Yes, I agree. Like typically, if you have 80,000 tests that run for 400 hours, this is not what anybody in the team wants, and also not how you would engineer this now. And typically, you would have what you would want is a test pyramid where you have very many low-level tests that are very fast, and not so many at the higher levels of the pyramid. And I mean, the test pyramid is an old idea, and one of the mental shifts I had to do when I moved from research into practice was not to preach how things should have been done to teams that inherited software and are not responsible for how it looks like. So I learned that if I only preach from the ivory tower that it's all wrong and they should have done this differently 20 years ago, then they say, okay, we know this. We are in this team for 5 years, and this doesn't help us to learn that several team generations ago it should have been done differently. So these analyses can contribute in coping with these situations, even while you re-engineer such a test setup towards a test pyramid that is way faster. Because often, if something like this grew historically over many years, you can't really re-engineer this in a couple of weeks. But it's also a big re-engineering project to build your tests in a way that they are fast enough.
Yeah, and also I think as well the internal team and the test maintenance, they should take some pride in the work. Like I said, they take pride in the work to realize, oh, I wrote that test 10 years ago, and I don't think that should be still within my test set. That should have been gone because with all the new, with all the new features and advancement with all the stuff you would use. So I think so. I have a question here, but Paul wants to know how easy it would be to implement. To say, easy would it be to implement?
Excellent question. It depends a bit on the analysis. Let me just go to the overview slide again. This first one, where's the most bugs, takes a couple of hours. You connect the tool, let it analyze the version history, and you see the stream map where were all the bugs in very short time. If you want to know where the test gaps are, this picture, it typically takes a week or two to get the profilers into all the test environments. And this means you need to schedule a month or two of calendar time until everything is in place, especially if it's a complex environment and we need to wait for a lot of permissions to set things up. And the last one takes the longest if we want to know which test runs through which part of the software, because there we need to measure individual coverage per test case. And this can be very quick, but this can also take long depending on how long the test suite runs. So this is really hard to generalize. But what we typically start with is test gap analysis. And then if we know the system well enough, we can do test impact analysis as well. Thanks.
All right. Yeah, thank you so much. It was very exciting, and for anybody who want to stay in contact with Elmar, yes, you scan the code, you scan the barcode there, and you could also find him on LinkedIn and reach out and have a chat with him. So Elmar, from
Larry, thanks.
And myself, it's lovely to have you here, and and hopefully we'll meet again somewhere.
Thanks. Have a good day.
Thank you. Okay, folks. So there we had Elmar, very, very interested and very informative presentation. I mean, I for myself, completely enjoyed it, and I'm definitely going to look into what's going on. So now, so that was Elmar, and now we have my next presenter is called Cristiano Cunha, and he will correct me. And he will correct me if I pronounce his surname wrong when he comes on. And there he is. How are you, Christian? And a little bit about you. I see solution architect, testing advocate, and what I like about what you do. And my first presenter is that he produced an X-ray of his kneecap to prove a point. And here you are, you're an advocate at X-ray, doing something. So I find that was really a very quirky,
a good connection of subjects. Yeah.
Yes, exactly. Exactly. And that in itself was, that's awesome. So, I mean, without having taken up any more time, what we're going to do here, folks, is you're going to hear Christian talk about how to stop the tooling avalanche. Christian, the floor is yours.
Yeah. Let me share my screen. Just making sure I have the right one shared. Sorry, a lot of screens here.
While you're doing that,
the entire screen is safe.
While you're doing that, I'll just remind people and pushing the plug here for Zappletech. They're doing a really wonderful job in giving us this forum to present all these lovely presenters to you guys. So a big shout out to Zappletech again. Christian, we can see your screen. Go for it.
Okay. Yeah, that's it. So I'm here to talk about a little bit of, a part of my journey where I was really overwhelmed with tools. So I'm here to talk about how I, at that time, stopped the tooling avalanche that was happening on that place. But before that, and thank you for your introduction, but I'm going to do it again. I usually use always now this presentation that Nikolai Advolkin did for me in the test automation podcast that he has. So I'm going to read it for you guys, and then I'm going to complete it a little bit. But it goes like this. So in the realm of code, where the tests are key, comes Cristiano Cunha, a legend you'll see. From X-ray by X-Plane, he crafts his design, making testing an art, not just a straight line. Solution architect in testing is grand, for deconstructing flaky tests is the best in the land. Today on our conference, well, we'll delve into the core of a tool adoption and oh, so much more. From TestSkill podcast to Systems the guest fame, is a voice in the field, a significant name. So tune in, dear viewers, for insights so grand. In the world of test automation is the man with a plan. Well, I really liked it, so I'm repeating it over and over every time I get the stage, and this is one of those times. But in a nutshell, like you said, I'm a solution architect, test advocate, and X-ray. X-ray is actually a test management tool that lives within Jira. And as many of us, I started as a developer, really, well, a long time ago, let's say, in mobile devices. And then the opportunity was presented to me to start being part of a quality team, still on the side, Silhouette team and things like that. And since that, I never stopped. So I upgraded into quality, into testing. And I really enjoyed it, and I continue my path. Really, most of my path was focused on automation, focused on then later on DevOps, into pipelines, into how to automate the full process to deliver things into production. So, and let me just start by saying that actually tests or quality is actually more than just tests. And I see a lot of times the discussions going into the specifics of should we use functional tests? Should we use security tests? Should we do this? Should we do that? And nowadays, I believe that the area has grown so much and evolved so much that the applications are not only simple applications that we put in production. They are actually big social technical systems that are actually composed by tools, software, and actually how people are interacting with it. So the tester role has also evolved. We are no longer the gatekeepers where we say if there are no bugs anymore on the application that it can go into production or not. And we are spreading the message. We are pushing the quality mindset towards everyone that is on the team. So help me spread the message. Sometimes we are fast into talking about the specificities of tests instead of talking about quality overall. And this talk is really about that, because actually I'm going to talk about how I managed to slow down the adoption of tools and how it actually has increased the quality overall of my solution. So let me start by sharing how all of this started. So I started in a small startup company where we were, 24 of people responsible for 2 big monoliths, the back end, the front end, and that was it. And well, we were full. We handle everything, since the coding, testing, not so much testing at that time, but coding, pushing applications to production, maintaining it there. And everything was going so well that we grew so much. Then actually we started to change the way things were doing. And we started to divide this team. So we hired more people. We divide the teams into smaller teams. We actually started to have testers and product managers inserted into the teams to have that kind of agile mindset adoption. And we started also dividing these monoliths into kind of a network of microservices. And of course, this has actually complicated things. And we had also, each of these changes is supported by tools. And each time we change something, even if the workflow or the process, we need tools that will support that, either adopting new ones or adapting the ones that we have. And of course, at that time, we wanted more. We wanted to be faster to deliver to production. We wanted to be able to put things in a more reliable and sustainable way into production. And well, everything was aligned. Then the DevOps movement started to appear, and we started to, well, probably DevOps is the thing that we wanted to do. And guess what? It will require tools also to be able to support this new change. So what do I want to say with this? Basically is, no matter where you are on your journey, either if you are fighting to have or apply the compliances that you need on your company, or adopting Agile, or shaping into DevOps, or adding security into your process, if you are choosing a specific tool or framework, like a testing framework, or even the big problem I had in the past was choosing the right temperature of the air conditioner. And believe it or not, we had a small tool just for a voting section for everyone to have the correct temperature. We never got it right, so don't let fool yourself. But that's it. So tools are everywhere, actually, and at the end of the day, the responsible adoption of tools will slow down your delivery and actually make your quality to decay. And that's what really happened to me. Throughout all of those changes, I end up being overwhelmed by tools. And, developers are characters that are really, let's say, the artists in our company. And as any artists, they want to have the cooler tool, the cooler framework to work with. And we cannot limit their liberty to choose that. So we were kind of, we wanted to reduce the adoption of tools, but we don't want to hinder their capability to choose those tools. But before jumping into the solution, let me just show you the real impacts that I felt throughout all of these changes, and because of that tool adoption. So I really start to felt impacts in 4 big areas. One was in knowledge, one more in the integration side of things. The maintenance was also a big pain that we have, and we will see that the impacts are connected to pain, and the standards. So starting with knowledge, actually what we started to see is that we had a lot of problems in the installation and maintenance of so many tools, because the expectation is all of the teams that are maintaining and installing tools into production need to have the knowledge to do so, needs to know how to install a proper application or framework, need to know how to react if something goes wrong, need to know how to maintain that tool into production. And that knowledge was not spread around. So if one team wanted one tool and he wanted to put it in production, that tool was not, the knowledge of how to maintain that is not flowing correctly. And it's just impossible to have one team to know all of the tools of all the company if we don't stop the variability of the tools that we are adopting. The other thing that is kind of linked to this one is lack of experience. So if we have a tool that's pretty recent, we don't have anyone with experience that will know what to do if something happens with that tool. And bear in mind that when we are putting things into production, we want everything to work. And if something doesn't go right, if it goes wrong, actually, we wanted to know who to call. And if no one has experience, that will be a big issue and a problem. Another one is visibility. When you start spreading and having multiple teams, and in one team you adopt one tool, and in another team you adopt another tool, there are no really any mechanism or process or workflow that will make that knowledge flow and that visibility be available for all of the teams, making that one team is adopting one tool that actually will solve one problem, that is the same problem that the other team will have, but probably the other team will adopt another tool. And then we end up having two different tools solving the same problem. So the lack of visibility is also an issue, or were also an issue. And by the previous example I just showed is also, with so many tools, they are so different things spread in different teams, areas, that everything starts to be scattered. And that is true for knowledge, and we'll see for the other areas around. But basically, we were asking the impossible. That is, at the time, we had one team responsible for production, and that team will need to know everything about all of the tools of all of the teams we have in the company, and know how to install, how to maintain, how to share that information. So it's just impossible. We needed to control that and to have a proper process in place. But the other pain that we felt was also in integration. And in here, sometimes when we adopt a tool, we are just thinking of how it will solve our problem. But actually, we need to think of how will this tool work with the system I already have in place for my company, for my team, for my process of delivery. And sometimes, even though the tool is the best one to solve your challenge, it is not the best one to have to integrate in your current system. So one of the things that happened to us is the tool was good to solve one specific team problem, but it requires too many steps to make it work. And when we wanted to go faster and faster, having too many steps, manual steps in the process was not what we wanted to have. So that was a problem in the integration of that tool with the current systems. The other one happened also was, but wait, if we have too many manual steps, we can build an integration that will solve that for us, and we'll create a custom code to integrate those two tools into our process in our system. But even this brings other sets of problems, because once you branch a code, or you create custom code to integrate one tool, you will need someone to maintain that code. You will need someone with experience with it. You will need someone that will react when a new version of that tool appears, if a change on that tool appears. And you know how the internal teams are. When you have a tool, they will need new things. They will want to add different things to it. So probably what will happen is everyone will need new things for it. And while we are asking to it, who will be responsible of the code? We will produce new versions. How will these new versions will behave into what we already have? What are the impacts of creating these new versions? So all of this started to build up and to create more and more problems into the adoption of tools. And yeah, and the other one is, of course, we need another tool to integrate this one, because with these two tools now we can integrate and make it perfectly fit into our system. But don't forget that as much more tools that you integrate into your process, it will create actually more failure points, and it will be harder to maintain, and the impacts will be harder to understand. And it's simply not one of the things we wanted to have. So the other big area that we felt problems with was maintenance, as I touched, linked to the knowledge. Like I said, more tools will mean more failure points in your process. So we needed to have that knowledge of how to maintain that tool, but not only the knowledge of that tool isolated. We needed to know what will happen if that tool will fail, and what happens to the process that will use that tool if it fails. Do we have alternative paths that we can use without that tool working? Will it break completely our workflow into production or not? We need to know what to do if that it's actually a failure point. We need to validate that extra failure point and know how to react to it. So maintenance and knowledge come tied together, and so we were thinking of, well, probably we needed to have less tools in production to reduce this. So we need to have the right amount of tools, let's say. And talking about production, if you had more tools into production, of course, it started to be a nightmare, because it's like I said, if you have, well, microservices is no easy. And if you start adding tools over it, it will be really hard to know what went wrong or what to do if it fails, or even if something appears into the version of that tool, meaning that if a vulnerability is found on the version that we are using into production, what should we do? Should we upgrade to the proper version? And what will be the impacts of the upgrade? Can we have downtime because of it? Should we not have downtime because of it? Does the tool provide the ability to not have downtime? All of those questions will be coming too late in the game for us. And well, when we were installing something into production and the teams were expecting to have that, those questions started to rise, but it was already too late because the release will depending on that tool. And we wanted to change that. So in a bit, we're going to see how we change this process. And the customization, like I said before, is also not only a problem of integration, is also a problem of maintenance, because we wanted to know which version of that custom code that we have works with X and Z version of what we have in production. So customizations will need a proper team to support. We'll need proper documentation, and we need persons with experience that will know or can help into understanding what will happen if something of this this possibility can happen. And one of the no-nos is having tools that are not yet official, meaning that we don't have yet official versions of those tools. So one of the things we did was well, no, we don't want to have beta versions, because one of the things is we don't have the ability, well, even if you have a beta version that is stopped in time, we don't want that, because we really want to install only official versions into production. Of course, it doesn't solve everything, but it brings us another level of confidence to see that we have an official version and that we have some teams working and we have a roadmap, and we know that a new version is coming, and we know that that tool is alive. And if something happened regarding security or performance, probably a new version can emerge, an official one that could solve our problem. Otherwise, we will just be by ourselves, and sometimes it's really hard to maintain that in production. And of course, a lot of tools will bring that problem that is, oh my God, how do I manage all of those licenses that I need to have into production? How do I know when a tool will end these licenses? Who will handle the process of acquiring a new license in time that the old one will be available? What will happen if that license ends before we are able to renew it? What will happen to the tool? Will it be read-only? Will it be totally unusable? What will happen into workflow? So all of those questions sometimes just slipped our minds, and we just focus on how good the tool is to solve our problem. But all of this comes attached to the adoption of a new tool. And one of my biggest concerns when we were adopting tools at that company was actually standards. And standards, when we were just a small startups, were not that big of I will not say problem, but will not bored us so much to look into, because, well, everyone was doing everything. But as you start to grow, you start to have more demands, you start to have different ways of putting things into production, and you start to have different needs and different expectations of your application and of your customers towards your application. So, for example, we started to be like one or two big monolithic applications, front-end, back-end. And as you remember, we shifted into a multitude of microservices. And while we were doing so, we also shifted into multi-region deployment into production. That means that we will have different data center, one for America, one for Europe, for instance, where the deployment process will push the application in both of those data centers to be closer to our clients. But then one of the things that we wanted to do is having proper logging, error messages, and performance of those microservices. And that actually was start being a problem when we went that path, meaning that I don't want to go to all of the machines that I have into production to see the logs and try to understand what went wrong. One of the demands that we have is we want all of the tools and applications and frameworks that we are installing into production to ship the logging into a central system that we have ready into production, and we can access to see all of the logs that are happening into production with proper identification, proper format, and all of that. Another thing that was happening is, oh my God, when you use APIs and microservices, you can have a multitude of error messages that says really nothing. So, and that started to happen. Or you have the proper HTTP errors, but the message is just gibberish. So it doesn't say you anything that will help you actually solve the problem or to understand what's the source of the issue. And we were also a little bit worried because we went from nothing to everything. So all of the messages were really, the error messages were really descriptive, and we know what would happen. But if we know, an attacker will know also. And revealing too much information on the error messages is also harmful. So we kind of had to balance a little bit between both and try to have a proper format that will let us know what's happening, but not too much that will let external attacker to take advantage of that. And of course, performance. When we have a system that depends of multiple calls of multiple services, all of those services need to have a certain expectation, a certain standard regarding performance. And we started to talk with teams and ask them, so what's the performance that you are expecting to have of this new API that you will build in the next months? And they say, and well, you know what the answer is we don't know. And that will not work. And I know that it's hard to try to understand how we want or to perceive how we will be the performance of something that is not yet built, but we need to have a target. We need to point to something, to need to have a goal, at least to understand that when I'm developing and we need to have performance tests, of course, to validate that the performance is what we expect it to be. And we need to go towards that goal. So we can start not that performant and then start working into having it to the standards that the company requires. Because if we have 5 microservices and each one of them take 1 second to process a request, it will just lose 5 seconds to process a request just because of the calls between the different APIs. So it doesn't make sense. So we need to understand how those microservices will interact and what's the performance of that experience where all of the microservices will be. And with that performance in mind, what each one of those services may have or lose into the performance that they are outputting. And of course, security, because well, we were an e-commerce site, and we know we have payments, we have personal data, PII data of our clients, and we start to have some requirements in order to be able to have those kinds of functionalities. And security was always present after that. Security in the logging. We cannot spill personal information on the logs. We cannot have too much things stated in the log. We cannot install certain application on the same security zone of other applications because they cannot interchange communications. So all of that needs to be defined from the starting point. So this was all our pains, all of our impacts. And we were having a lot of suggestions of new tools coming from different teams. And well, in the past, we just accepted it and installed into production, but that we were just pushing the problem into production, and then it will just came back to us. So we started to think, how can we start? Remember, not limiting just because we want the adoption of tools for the developers and the teams, but try to control and make them understand what it means to adopt a new tool in this company. So actually, sorry, I just heard a peewee. I was just checking if it's something that was someone talking to me, but no. So we kind of find this technology radar that was actually put out or shared by Zalando. It was actually ThoughtWorks initial effort that was there. And it actually is a tool. Well, yes, I'm going to adopt a tool to solve my problem of tools. But the technology radar is supposed to be a snapshot of the tools, techniques, platforms, languages, and frameworks, but based on practical experience of the workers of your company. In this case, this is the definition of ThoughtWorks, so thought workers around the world. And this is actually a radar that is divided per areas. As you can see, we have different areas, so there are different buckets available where we divide the tools and frameworks that we are either trialing, in use, assessing, or not using. And then we place them into a radar of adoption. And that will bring actually visibility for all of the teams. It allows us to have a separate evolution of each one of the tools throughout the rings. And I'm going to talk a little bit about it further ahead. And it helps us also enhance the search. So as you see, the radar has actually 4 rings. We have the in-use rings. It's actually the technology that we know that we can use, and we know that other teams are already using. So we have the knowledge, we have the experience, and we know that it's following all that we have defined into our tool process adoption. So these are the okay tools to use. If you have an issue, if you want to solve a challenge, you will go, the first instinct will be, let me go to the radar, see of the in-use tools, if I can use anything from there that will solve my problem. If not, you have also the ability to trial some of the things. And this is the other outer ring, are the tools where some engineers have already walked this path and share knowledge. These are tools that are already being experimented by some teams in production, but are not yet approved. So they are in the trial process, making sure that they are fulfilling the standards that we are expecting for logging, for performance, that we have the correct knowledge in place, that we can share information and documentation that are valuable for all of our users. They are still on trial, and one of two things can happen is either it will be in use, or it will not be evolving into in use and probably fall back into assets on hold, depending on the conclusions that we will have. The other ring is access. So we have some tools that are promising. We know that they may have value to solving our issues, but we don't have yet anything defined regarding experimenting them. So we are just assessing if they are valuable tools. If we don't have any tool within our in-use or trial rings that solve already that kind of challenge, if they probably will be able to follow our standards. And this is how everything starts. It's on the access ring, actually. And of course, we have also the old ring. The old is the not recommended to be used, not worth investing into. This ring will hold all of the tools and frameworks that we choose, or the company choose, that will not use, either because the process of adoption didn't go well and it doesn't make sense to adopt, or we know beforehand that there's no way that we can use those tools given what we expect them to be on our systems. And another piece of information that is important, so below what we see that I just show on the actual radar with the areas, we also have on the bottom this kind of information. Because once you start sharing this information, you need something that will explain what is a take radar, because, well, you must assume that not everyone in your company will know what this is. You need to know what is the purpose of it and how do we maintain it. This is important because the process of adoption needs to be present in everyone in your company, or at least in the majority of them. When someone asks about it, someone in your team must be able to recognize what is a technology radar, how to do it, or at least pointing into the link and to knowing more of the radar. So this is a good tool, but we still need to implement it, because this tool is cool once you have already the process in place and you are just showing the results of it. And for us, implementing the take radar was actually, we needed, well, I'm going to, a lot of steps, but the 4 big ones was actually how to infuse the standards into process. How did we find our champions? How do we will process, and for us it worked on monthly basis. So how did we evolve the tool adoption itself in the monthly spotlight, and what kind of visibility we wanted to have? So regarding infusing standards, it was actually a very good way for us to start talking about standards, understanding what are company standards, what are our company standards. And you'll know that the company standards will evolve along the time and are not the same for all of the companies, depending on the business you are trying to do, depending on the support where you want it to be. So it's a really good way to understand first, what are the standards in your company? What your company expect of your applications and services that you have in production. And this is really focused in production. If you want to adopt a tool that will never be used in production or in the process of putting things into production, you can use it and not follow the process of adoption. If you expect it to be installed in the software delivery lifecycle or in production, you need to follow the standards. And you need to make the standards part of the process, meaning that the tool adoption process that we'll define, and may be different for every company, must have ways to make sure that the standards that you just talked about of your company are part of the process. Meaning that even if one team does not know that we need to have a centralized logging system, when they are adopting a tool, the process will lead them to that. Meaning that throughout the steps of the process, one of the steps will be, are you pushing the logs into this system? And they say, no, why should I? Because we have a central logging system and all of the logs are going there. And we have documentation supporting that. And we have other tools doing that. So you can have examples of it. And documentation, of course, you need to create documentation that will support the process of adoption. The radar is actually one of those pieces. That is actually the entry piece. And I haven't shown, but each one of the dots within the radar will have information of that specific tool. Who is, what is the version that, or versions that we support, who is using it already, and all relevant information that you think it's useful for each one of the tools. And you need to cover everything that your company finds that a standard is important to. Security, performance, compliance, or any other thing that you need to have. So on my examples, so things that we did in order to infuse those standards is actually, well, the central logging system and all of the frameworks and languages that we are adopting will need to have the ability to send that to the central logging system in a correct format without leaking PII data. And that's tricky to do, but, well, we needed to have some tools and eyes validating that. Of course, the testing tools for us mean that we need those tools to integrate seamlessly with Jenkins. That was actually our orchestrator to put things, to build our pipelines and put things into production and produce unit results. Because we were at the time working with SpecFlow over the unit results to produce those reports. So we needed to have that available and compliant with the test tools. And while we evolved towards DevOps, we also made changes into the development and into how the infrastructure would handle into production. And for us, we started to use Docker and images. And it actually helped us because we infuse within the Docker image the security tools that will need to be installed in each and every application that we wanted to have in production. So the base image that was allowed to be used within the company was only the one that was already infused with security and traceability and monitoring tools that we wanted to have within our company. So that was one of the things that we did to assure that the standards were already being followed. The other thing was find champions. You know, we cannot do this alone, and we cannot involve everyone in the company. It's impossible. And, you know, there will always be the ones that say, well, why did you not invite me? But because we cannot invite everyone in the company to be part of our champions to represent this adoption. So choose representatives that are actually involved, meaning that they are present not only in more experienced circles, but also into the teams that are able to discuss technicalities and overall architecture to understand how will that tool, how that framework will fit into the system. They need to have that kind of knowledge. They need to be involved within the team. So having the synchronicity between what the teams are asking for and what the radar is having, and is the channel that will push information back and forward towards the teams, and that are also decision makers, that are ability to provide a decision of, well, together with other champions, if we are going to adopt, to assess, to hold some kind of tools or frameworks. For us, what worked was actually architects. We have a mix of champions with architects and senior infrastructure engineers, because the architects were in our company were divided into pillars of teams, and one pillar was like a set of 4 teams, and that architect was responsible for that team and deciding how those services produced by those teams will fit within the overall system that we have. And the infrastructure engineers actually were the ones knowing how production works, how security areas are defined, what are the machines, the VMs that we are using, what are the Docker tools that we are using. So it was a good mix of champions that we find to be representative of teams, of what they need, and also capable of deciding what to go, what to evolve towards production. And we give it, like I said, a monthly spotlight. That means actually that we have the ability to every month gather the champions, and every time that we need to take a decision between the rings, the teams involved into that assessment is also invited to this meeting to show up the results that they have, where we actually discuss the evolution through stages. So we assess the results of the experiments of the teams. We assess if something, or what is the process if we want to pass a tool to hold because of whatever reason, and what we need to do. Also identify what are the teams that are using it, identify what are the steps to take every team out of it. And it can be different for everyone. They need to be present, so they need to be present in all of the meetings. So the monthly spotlight need to have the representative. If you don't have quorum, don't do the meeting. It will not serve nothing. We need to make sure that the information is updated on the radar, on the documentation sites of each one of the tools. And for us, it was actually a monthly meeting. And of course, at the time, to spread information, it's just pushing an email for everyone. Yeah, it's another email for the trash, but the information is there. If you want, you can go to trash, assess the link, and see what changed, what not changed. And of course, the online Take Radar is a link that is available for the entire company to go and assess. Of course, you need to know the link, but it's on the email. It's on, someone will know it, or else we didn't do the right job. And visibility, because if we do all of this, but you don't bring visibility either to the information produced or the process, it doesn't serve you. It doesn't serve for anything, because nobody will know about it, nobody will follow it, and it will be hard for anyone to comply with it. So define your Take Radar, and you can adjust it. You will see that this is a version that is a little bit old. There are already evolutions over it, where we focus in one thing, where we change the rings into different ones that are more suitable to your process. You need to be really, it's really important to keep it alive. So update, share it to everyone. Make sure that the link is available 24/7, because if someone needs to choose a tool, they need to be able to assess that information and share the process with everyone. This is the part that is a little bit tricky. Like I said, we try having an email. We have an online endpoint accessible to everyone, and we try to start infusing on the onboarding of everyone that was joining the company this information. So one of the pieces of information, one of the things that were talked into the onboarding of each one of the new members of the company is actually the tooling adoption process. So this kind of solve most of our problems. And I believe that's it. So my message for you is, if you have too much tools, you feel that you don't know the standards of your company, or you think that, well, it's a mess to maintain things into production, or you just don't know what the other team is using, start suggesting a technology radar. Start small, start with an area with, I don't know, quality. Start to know what are the tools that are in the company being used for quality, what are they solving, try to gather that information, find the right persons, find your champions, try to find what is a champion for you, and then start gathering that information, share it, and you'll see that more and more people will want to get involved, and we will find the right champion. Champion is also something that evolves throughout the time as the company also reorganizes itself. But you will find that it's an iteration that you need to have for adopting the right things, to evolve into the right process also. We will not nail it at the first time. So experiment, evolve, and let's try to stop the tools avalanche together. And actually, that's my last slide. So I hope you enjoyed. I sure did. So thank you, everyone. Any questions?
Thank you, thank you, Chris. Yeah, I actually, very informative, by the way, and I like how you solved the whole tool avalanche within your own company domain. That's brilliant. I have a question here, and the question relates to the actual tool selection. You come into a company, there are a lot of teams doing a lot of different things. How do you go about deciding which tools to keep and which ones to get rid of in your tool selection?
Yeah, that's the answer from the more experienced testers is always it depends. But it really is. So it depends on. I will say for us, when we started this and we started to see see everything or every tool that we'll use in the company, and we started to have a list of those tools and understand first what are the teams that are using it, what are the applications that are using it, well, linked to the teams, to understand what are the impact of removing such a tool. And just with that information, you can already remove some of the tools. You also need to find common challenges from the team. So what are they trying to solve with that tools? Because sometimes they have tools that are solving the challenge, but not on the better with a better experience. And we have other tools, sorry, that allow them to do so. So have an overview of everything that is being used, understand what are the usage of each one of the tools, and then start looking at the standards. So what are the standards in your company? Look at if that tool is able to, for me, is able to produce logs in the central logging system, is able to have the correct performance given what I expect. If not, is it the right tool to have? So starting to have those questions. It's not a written process, but I think it's something that you need to adjust to your needs in your company.
Yeah, that's brilliant. That's really good. But now we have to think about, you have, let's say, team A, B, and C. Now team A, B, and C, they work on completely different projects, and they use completely different tooling. Yeah, and the argument is, but this is the better tool for what I do, and this is the better tool for what I do, and this is better for what you do. How do we as a company, that's the way to say it. How do we then as a company put together something that would say, okay, out of all the tools you guys using, you know what, this one here will do all this, and this one here will do all that. And then how do you deal with the pushbacks from the people who are going to lose the one they have to adopt this new one?
Yeah, that's the hardest of the process. First is they think that we are trying to limit their adoption, what is not true. We're trying to guide their adoption. So having that change of mindset is already one challenge. And then when we came up to that kind of decisions, bear in mind that it's not, when we say the company has chosen this tool, it's not really the company. It's the mix of the more experienced persons in the company. So the champions you have chosen should be representatives and understanding of what are the standards expected from the company, what are the tools, what are the architecture of the systems that you have, what are the organization of the infrastructure that you have in production, giving all of that. And the decision is not taken by one person, it's taken by the community of champions that are representative of the teams. So, and well, you have to live with the choices. At the end of the day, also, what happens is the company is here to produce money most of the time. So you are working towards that. And if the company have certain standards, it's not not how do I say? It's not easy to say no to a team, but sometimes you have to do it and cope with the decision and try to help them migrate. I think that's a big must. That is, understand what is the effort into migrate to this new tool, and sometimes, and we had like migrations that took years. Depending on what you wanted to do, how the application works. And remember, when you have monoliths that have old versions of old frameworks that nobody touches, getting out of it takes a lot of time. But making sure, for instance, that the new things that you are doing will follow the new tool that you are adopting. So for at least the new things, will be on that new tool or framework or language. And eventually, the other one will follow. It's not easy. It's not just a decision that slices and says, well, you stop now and use the new one right away. You need to have openness for adjusting the migration of those tools for each one of the teams, and show them that even if it's not the best option for them now, it will be for the future. So it's an investment that they will need to do.
Okay, that's lovely. Now I have a very interesting question for you, and I thought about it, and I thought to myself, you know what? Yeah, here it goes. This is your personal. This is a personal opinion we're looking at here. In your personal opinion, right now, do you think companies or do you think companies should adopt a lot of AI-related tools? One, and two, yeah, it must be us, right? Because we're in the AI revolute. So, and that's one. And two, do you think the use of, let's say, AI toolings or AI-powered toolings, or any way you want to phrase it, is good for the system? And if so, why?
Well, this is again my personal opinion.
Yes, your personal opinion.
I don't think we are in the stage where the AI tooling or assistants or whatever are in the state where they can be just used straight away in your processes, in your companies. I believe they started to be really helpful assistants, giving you ideas, giving you or helping you in tedious tasks, but they are not yet, I wouldn't trust the output of those tools yet 100%, meaning that all of the outputs of those tools need to be reviewed by someone with experience to know what they are, to control what they are doing, because some of the results are so far-fetched sometimes that we cannot trust them. I believe, though, that if we don't start to have tools with AI abilities in your assets ring, in your company, you will fall behind in the following years. So I would say, no, I don't see any, for the moment, I don't see any tool that yet is ready for be using 100% on a company yet. I see good progresses, but I will say that we will need to be aware of what's happening, because if you miss that boat, you will for sure lose. And that links to what the impacts that you were talking about. So what the impact of having, imagine that we have such a tool within. So for me, those tools are still lacking the context, the understanding of your company, meaning that they are so generic yet that they will suggest you more generic things. They are good, for instance, if you look into quality to say, I'm going to test login operation. What are your tests that you suggest for this context? And they are good to start pitching ideas from it, and then you evolve over it. I believe that's useful. But just clicking a button and say, generate tests for the logging, run them, and if they fail, I will not deploy into production, I don't believe that will work. So
Yeah.
it's a tricky question, but I really would love to see good tools. But I believe that sometimes because we are so used to tools nowadays, that we are not used to have a tool that will need to learn before being used fully. So if you purchase a tool that have AI in a generic way, you will need to give him time to learn your context, to learn how you work, what is expected, what is your workflows, for him to provide useful information. If you just expect them to know everything and just put an optimal solution for you, you'll be dead wrong and it will not go well for you.
Yeah, I mean, like I say, it was one of them, your personal thoughts, and I just had to put it in there in the context because, as you know, everything is all AI. And yeah, so Christian, thank you very much for this chat. Very, very interesting. It was lovely having you. It was lovely having you on the talk.
Thank you. Thank you for having me. I loved it also.
Thank you. Yeah, so yeah, folks. So yeah, this brings us to the end of our session for today. As you see, we had Elmar, and who talk about test intelligence and how we could find more bugs in less time. And we just wrapped up with Cristiano talking about how to stop the tool in Avalanche. And it was good. And again, we want to thank Zappeltech for giving us this platform for having these lovely conversations and sharing the knowledge with you all. So on behalf of myself, Larry Goddard, and Zappeltech, I'll say thank you very much. So good day, good morning, good evening, and good night, depending on wherever you are in the world. And hope to see you on the next session. Have a good one. Bye, all.